Good morning. It certainly is a pleasure to be here again and to be talking to you. What I want to do first of all, before I start my presentation, is to make an award which was conceived by my colleague Ken Harpelaw. Some of you may know him. He is the editor of the Week That Was, which is our weekly bulletin. Ken thought up this idea and carried it out, and he's asked me to bring it here, this award, and make the presentation. Just to give you a little background, it calls the April Fool's Award. It's sort of a joke, a little bit of a joke. We set up a panel, that Ken did, and to nominate a politician or government official who's made an important contribution in the following way. He has to have advanced regulation to control the economy. He had to declare that these measures are absolutely necessary for human welfare. He had to also declare that this is supported by science, but it turned out the science doesn't support the measures or the regulation. So we had lots of responses, and there were 12 nominees. But then the panel found it very easy to select the right one among the 12, and I'm happy to announce that the distinguished recipient of the first annual SEPP April Fool's Award is none other than America's own EPA Administrator, Lisa Jackson. And in her honor, this special award was constructed, and this distinguished lump of coal will be known as the Lisa Jackson Trophy, or simply the Jackson, and will be given to DDP to be awarded annually as they see fit to the successor, but the Jackson will be the name of the award. Thank you very much. Thank you, Jeremy. Well, my presentation is mainly about energy, but I cannot talk about energy without at least mentioning the scare about global warming, anthropogenic global warming. So what I plan to do is to concentrate on energy policy, and give you the ammunition which will allow you to debate proponents of AGW, particularly catastrophic anthropogenic global warming, so that you will be able to have enough material in hand to debate anyone who claims that this is a real threat to humanity. I think I can figure out how to do that.
And here's a laser pointer. Laser pointer.
Oh, this?
Forward, backward, laser pointer.
Okay. Forward, backward, and pointer. Okay. The energy policy goals are very easily stated. What we need is lower cost and more secure electric power through higher efficiency and resource conservation. I'm very strong on energy efficiency and conservation, and I think we all are, and that I think should be the real goals. And here I think we should try to enlist broad support from all sectors of the population, irrespective of how they feel about climate issues. Energy efficiency and resource conservation is clearly important. We want cheaper transportation fuels, and what this does, in a very important way, is to lead to greater economic growth and prosperity. And I'm delighted to see that the theme of this conference is energy abundance versus poverty, because that's exactly what I'll be talking about. That is the whole issue. For some reason or other, the candidates running for presidency this November have not caught on to this. In the case of Obama, in fact, it's the opposite. He's been arguing for higher energy cost and not realizing that this will depress economic growth and increase the poverty problem. And we haven't heard much from the other candidate, Mr. Romney, but I hope we will. In the meantime, I'm happy to see that others running for Congress are fully aware of these facts and are pronouncing them loudly and clearly, and I hope they will be listened to. Thank you, Art. In this business, climate concerns are mainly irrelevant. They need to be met and discussed, but they're not really important. The issue is not climate. The issue is energy, low-cost energy, and secure energy. And that's what I will concentrate on after I get rid of the environmental climate issues. So, how to reach these goals? First, to overcome the hype and fears of catastrophic anthropogenic global warming. Next, to take advantage of the fact that we now have cheap natural gas, and I can't resist quoting Nancy Pelosi. She's really wonderful. She says, we should replace fossil fuels with natural gas. Well, we agree. Natural gas is, in fact, become the answer. Natural gas has become so cheap that it is now competitive with coal on a BTU basis. But that's deceptive. It's more than that. Since natural gas can be used more efficiently than coal, it is actually a great deal cheaper to produce energy from natural gas than it is from coal. And I'll try to illustrate this. There's also the possibility of direct conversion of methane into gasoline or diesel, the transportation fuels. The ratio between natural gas prices and oil prices is so large that substantial profits can be made by converting natural gas directly through chemical engineering into transportation fuels, liquid fuels. No need to fool around with methanol, ethanol, or hydrogen economy or anything fancy like that. Just convert it directly into gasoline or diesel and use it, and it'll be cheaper. And if I were a candidate running for office, I would promise to bring gasoline, to bring transportation fuel prices down to $2 a gallon. It can be done easily by simply making transportation fuels from natural gas. On power generation, efficiencies can be raised considerably. You all know that 1 kilowatt hour is 3,412 BTUs. That's the magic number, 3412. When I started in this business, some 30, 40 years ago, it took between 10 and 12,000 BTUs to produce a kilowatt hour. My friend Quark Hayden tells me that efficiencies were much, much lower at the beginning of the century, probably the order of 1% or less. In other words, it took 30,000 to 40,000 BTU to produce a kilowatt hour. It is now reaching about 6,000 to 7,000 BTUs to produce a kilowatt hour if you use combined cycle power plants, which is easily done if you use natural gas. And the magic goal, of course, is 100% efficiency. We'd like to aim for that. May not achieve it, but this is our aim. And the way to do that, as you can see, is by not just only combined cycle, but also combined cycle plus cogeneration. Yeah. I hope you can see this. Cogeneration means that you use the waste heat, which is formerly wasted and has to be disposed of, and you make use of the waste heat to heat houses, to do useful things, and thereby reach a higher overall efficiency. Some people call it using the squeal of the pig. Not just every part of the pig, but even the squeal of the pig. Anyway, I will get back to these points in the end of my talk, but first I would like to discuss how to deal with alarmists, climate alarmists. So what I will now do is to switch discussion and go to climate alarmism and try to equip you with arguments that you can use in debates against climate alarmists. I have found that the thing to do when people talk about climate problems and become alarmed is to simply ask them, what is your single most important piece of evidence for anthropogenic global warming? That kind of sets them back. What evidence do you have? And it's important in this discussion to put the burden of proof on this other side. It's their job to support their claim with evidence, because they are asking us to make all kinds of sacrifices, to make policy changes, to raise the price of energy, to do all kinds of insane things to combat an imaginary disaster from climate change. So you ask them, what is your single most important piece of evidence? I get the following responses. Number one, carbon dioxide is increasing. Okay, that's true, but that doesn't necessarily mean that there's a climate problem. And then you get an answer that says, well, climate models show warming. That's also true. They do, but models are not evidence. And besides, the observations don't agree with the models. So the models are not validated. And then you get somewhat irrelevant responses, like glaciers are melting. Okay, glaciers may be melting. Some are melting, some are not, some are growing. It simply shows that temperature does have an effect on ice. We know that. The important thing is, what does it tell you about the cause of melting? And the answer is nothing. You cannot deduce the cause of glaciers melting from the fact that you see a receding glacier. All you can deduce is the same thing that you can deduce from thermometers. And I personally prefer, and you should tell them, that the way to measure temperatures is to use thermometers, not glaciers. It's very simple. It's an irrelevant issue. The other one is sea levels are rising. The answer to that is sea levels have been rising for 18,000 years. Usually at a much faster rate than they're rising today. The rate of the last century was approximately 2 millimeters, a little under 2 millimeters a year. That amounts to something like 20 centimeters a century. This has been the rate for the last 2,000 or 3,000 years. This rate will continue no matter what we do. I can vouch for that. This is one of our specialties. But unfortunately, the data are somewhat uncertain, and there's always latitude for argument. But I'm convinced that by the year 2100, sea level will be approximately 6 inches higher than what it is today. Not more, not less. Incidentally, the alarmists actually give you numbers that are much, much higher than those quoted even by the IPCC. IPCC has extremely wide limits on their estimates for sea level rise, which can encompass almost anything. And then you will hear about storms, droughts, floods, all kinds of disasters. I'm not a specialist in these matters, but those who assemble statistics, tell me that there hasn't been any perceptible trend in climate disasters in the last couple of centuries. I'm willing to accept that. Finally, you'll get the more sophisticated people who will tell you, well, the IPCC claims that there is anthropogenic global warming. And your answer should be, okay, let's see if their evidence holds up to scrutiny. And that is what I'd like to discuss, to show you that the IPCC evidence has no value, doesn't hold up to scrutiny, and is actually self-contradictory. But first, I'd like to deal with one other response that has been very, very common recently. People will tell you that X number of years in this past decade have been the warmest years in, let's say, X years, you name it, in the last 100 years. That may be true, but there's a logical error here that you should point out. The error is that they confuse temperature level, measured in degrees, with temperature trend, measured in degrees per decade. It's true that this present decade is the warmest in the last 100 years. But the trend in this past decade has been essentially zero. And that's the important fact. It's the trend, because the trend is what counts when you compare with trends in greenhouse gases. Why is this decade the warmest? Well, it's because the climate is still recovering from the Little Ice Age, which had its lowest point around 300 or 400 years ago. And I expect that we'll have another century or two of general warming or spasmodic warming, not related to greenhouse gases, simply because the climate moves in cycles. And this, we think, is part of the grand 1,500-year cycle that has been going on and can be seen clearly during the last ice age and less clearly during the current Holocene. But it's there. The evidence has been established by a large number of observations. I prefer to call it the Bond cycle, after Gerard Bond from Lamont, who first pointed it out in deep sea sediments that he studied to see the cycle of 1,500 years. And he believes it's due to the sun. Could be, I can't think of any other reason why there should be a 1,500-year cycle. But it's hard to prove these things because we don't quite understand how the sun works. In any case, the natural cycle exists and has been demonstrated by observations. So let's look at the IPCC. IPCC, in their most recent report, first of all, I need to point out, IPCC has now published 4 reports. They call them assessments, starting in 1990, then the next one in 1996, then in 2001, and then in 2007. It's the 2007 report, the most recent one, that has the following claim. It's in the SPM, the Summary for Policymakers, on page 10, right up in front, where everybody can see it. And it says, most of the observed increase in global average temperature in the last 50 years or so is due to anthropogenic increase in greenhouse gas concentrations. That's an assertion. And they claim to be over 90% sure. I don't know how they do that. I think they sit around a table and say, how sure are you? Oh, he says, well, 100%. Oh, you can't be serious. Can't be 100%. It's got to be less than that. Oh, let's say 99%. Okay, between 90 and 99%. That is the meaning of very likely. They define it, actually, as between 90 and 99%. So they're 90 to 99% sure of this. But what's the evidence? Well, if you dig into the report, get rid of the summary now and dig into the report, and finally get to page 684. That's well into the report. And you find there one graph which claims to show a large gap between reported observed warming and what the models predict without greenhouse gases. And then they make the fantastic claim, since there's this gap, it must be due to greenhouse gases. Yesterday we had a discussion by Matt Briggs. I wish he were here today. It's one of the fallacies that he discussed. If you don't know what the cause is, you assign a cause and say you're absolutely sure it must be that. It can't be anything else. I'm going to show you that graph and let you judge for yourself. This is the famous graph. It's figure 9.5 in chapter 9. Chapter 9 is called attribution, which means it tells you what the causes of climate change are. Attribution. It attributes them, in this case, to human causes. But the evidence, very flimsy. Look at it. First of all, here is the reported observed warming. Temperature in the last century. Actually, this is temperature anomaly. There's temperature measured against some base. I forget what the base is. But you see here a warming between 1910 and 1940. That warming is genuine, in my view. It really existed. It's seen independently in proxy data. It is real. Has nothing to do with greenhouse gases. In fact, they don't even claim it because the models don't incorporate greenhouse gases. The models are this blue mess here. 14 models put on top of each other. And then they report a warming between about 1970 and 2000. That warming may not be real. And the reason I say this, and I'll demonstrate this to you, is because we don't see it anywhere else in any other data set. It is only seen and reported from land surface stations, weather stations. It is not seen in ocean data, it is not seen in atmospheric data, and it is not seen in proxy data. So there are 4 data sets that don't show this warming. The only one that does show it is data set number 5, namely weather station data. It may not be real. There's something wrong here, and there are a number of people who are trying to figure out just what is wrong with the surface data. By the way, the weather station data are all based on the same basic material, of course, readings from weather stations, agree amongst each other, but that's not independent confirmation. The fact that NASA, Hansen's data agree with Jones data in England doesn't mean that they're verified, because they use basically the same data set, the same raw data. They differ only in the way they analyze the data. The most recent analysis of the weather station data is by Richard Muller at University of California, Berkeley. And in today's New York Times, or maybe tomorrow's New York Times, I'm not sure when, you'll see a front page article about this, because Rich Muller now claims that he's found a smoking gun for anthropogenic global warming. He doesn't have a leg to stand on. It's all, as Paul Dreesen would say in his native Dakota dialect, Wakonka Chesley. I hope I'm pronouncing it properly. My Dakota is pretty rusty. We have reanalyzed Rich Muller's data and submitted a paper for publication, and we don't get his result. We find a different result based on our own analysis of the same data. So there's something very, very wrong here. We don't know yet what it is, but we can certainly appreciate why Rich Muller is trying so hard to defend a point of view that this is anthropogenic. Because he spent $600,000 on the analysis of the data, and he has to justify the expenditures of this large amount of money in some way. So he's come up with this result, which he will present to a Senate committee chaired by Senator Barbara Boxer. That should tell you everything. Barbara Boxer of California. Yes. Okay. So what is wrong with the IPCC evidence? You see, they claim, of course, that this reported increase they think is real. I don't think it is. And they show a gap between the observations and the models. And to fill this gap, they say the only way to fill this is to assume that if you stick greenhouse gases into the models at the right amount, with the right sensitivity, you can account for the gap. Unfortunately, the models are chosen with certain parameters. And it's a matter of what I call curve fitting, because the parameters are arbitrary, chosen by the investigators according to their best judgment. But there are like 100 parameters that have to be chosen. And there's some crucial ones that relate to clouds mainly. And these determine the output of the model. That's why models disagree among each other. Each investigator has a different set of assumptions about parameters. So curve fitting is what accounts for these differences. And I just want to show you how that's done. The evidence they show is only for global averages. They don't show this for northern hemisphere, southern hemisphere, or tropics. And I suspect that they would not find a good fit because it only fits if you take global averages. And the evidence is only shown for land data, surface data on land. You don't get the gap that I show here if you use ocean data or atmospheric data or proxy data. But without this gap, you cannot support the claim that there is any significant amount of anthropogenic global warming. So what we cannot eliminate, and we don't eliminate the fact that there may be some human influence on climate, we can say that the evidence that they present doesn't support an appreciable amount of global warming, anthropogenic global warming. It is not significant. Or in other words, the sensitivity to greenhouse gases is very, very small. This conclusion, by the way, has been reached by others, and this is just another way of restating it. I'd like to show you, tell you about one very amusing anecdote. This is reported by Freeman Dyson about curve fitting. Here it is, yes. And Freeman Dyson reports this statement by John von Neumann, famous mathematician, who said, give me 4 adjustable parameters and I can fit an elephant. And give me 1 more and I can make his trunk wiggle. I don't know if he actually said this. I knew him during the war, he was the man who first suggested building large-scale computers for weather studies. And this was eventually done. And he did many other important things in mathematics, which I won't have time to relate. I will skip very roughly and quickly over solar effects on climate because it is not relevant to our discussion. But I would like to show you that the satellite data do not show a warming between 1979 and 2000. And this throws a great doubt on the land surface data. Why don't the satellites show a warming? The satellites are the only true global data we have. Here they are. You see that between 79 and 2000, you essentially get no warming trend. It doesn't go like this. It goes like this. Then you have this spike, which is 1998 El Nino. Just ignore that. It lasts for 1 year. Then it goes back to the same value. Then there's a jump. Then there's no warming in the last decade. So you have no warming, a jump between 2001 and 2002, and again, no warming. The satellite data, atmospheric data, do not agree with the surface data. The satellite data are independently confirmed by balloon-borne radiosondes. They show the same result as the satellite data, so we're fairly sure that they're both correct, because these are independent data. How about the ocean data? Ocean data are very hard to analyze because there are so many ways of measuring ocean temperatures, sea surface temperatures, which are inconsistent with each other. I've worked on this problem, and I can tell you that there are inconsistencies, unexplained inconsistencies among the data. The only data I found that I would consider reliable are data of the atmosphere temperature just above the ocean, so-called nighttime marine air temperature, nighttime marine air temperature. These have been analyzed by a British group at the Hadley Center. They've published their work, and I think is accurate and reliable as far as it goes. Certainly more reliable than the sea surface temperatures that are currently available. Here's what it looks like. And what you'll notice here is that the warmest years are around 1940, and the 1990s are maybe as warm as the 1940s, maybe not. But there certainly is no large increase between 1978, let's say, and 2000. You don't see this rapid rise. This is just a slight rise, a slight recovery, but the warmest years are around 1940. Finally, yeah, I show here two. I show here global average temperatures and tropical average temperatures. They're somewhat concordant. There's some slight difference between global values and tropical values, but that shouldn't detain us. Now I'd like to finally show you proxy data, which are completely independent of everything else. Proxy data are obtained from tree rings, ice cores, lake sediments, stalagmites, corals. In other words, non-thermometer sources. They measure temperature indirectly. Geologists understand how to translate such proxy measurements into temperature. And they've done a considerable amount of work, which is generally accepted. It's not disputed. But these are the only non-thermometer data we have, which are completely independent, and they generally refer to the Earth's surface and sometimes to the sea surface. Let me show you what they look like. Here's the first one that I found. This is from Lamont, Columbia University, Lamont Laboratory. You see here tree ring data showing a warming between 1910 and 1940. Very clear, completely in support of the weather station data. But you see no warming of any sort after 1940. Ice core data show the same thing. They're from Greenland, of course. The ice core data from Greenland show warming between 1910 and 1940, and no warming after 1940 till the end of the century. No warming. No further warming. I'll show you some more, just to convince you that these are not flukes. This is the most recent one, published in 2012, published this year, in other words. It shows the last 2,000 years. We're not too interested in that at this time, but let me look at the last century. You see the increase between 1900 and 1940, a maximum around 1940, and then you see no really further increase after 1940. Here are some more. Some of these are tree rings, some of these are lake sediments. Generally speaking, these values jump around a lot, but there's no warming after 1979. So it does not confirm the weather station warming that's been reported. So the upshot is that the IPCC bases everything, the whole conclusion about anthropogenic global warming, on land surface stations, on weather stations. But these data, the warming that these stations show, is not confirmed by atmospheric data, ocean data, or proxy data. That's where things stand. So if someone tells you there's warming, ask them to explain what's happening in the atmosphere. And if they can't explain that, ask them what's happening in the ocean, and then ask them what's happening to the proxy data. I would like to get back to energy quickly. Let me end my climate discussion by climate conclusion. IPCC claim is based on flimsy evidence, curve fitting. We find no independent evidence in the temperature data from ocean atmosphere proxies. And we conclude that the current warming is mostly natural, that the human contribution is minor. We can't even be sure how large it is, but we're sure it is very small. It cannot be accurately measured. Now, what about energy? Natural gas is cheap and clean. And this allows you to do several things. It allows you, first of all, to direct conversion. Into gasoline to diesel. The ratio between oil prices, gasoline prices, diesel prices, and natural gas has been 7 to 1. 7 to 1. Natural gas at around $2 a million BTU. Oil at around 100, was at around 110 when I drew this up. It's now down to about 90. So it's gone down, it's maybe 6 to 1 now. That's a huge ratio. That means somebody can risk building a plant and maybe make a lot of money. And several oil companies are doing just that. Shell Oil has built a large plant in Qatar that's already in operation, converting natural gas, of which Qatar has a huge amount, directly into transportation, liquid transportation fuels. But the real advantage is in electric generation, and that's what I want to talk about. Natural gas is so clean that you can actually put it inside a small city, inside a populated area. You can't really do that with coal. First of all, real estate is expensive. Where would you put the coal pile? The coal pile is kind of dirty. It kind of blows around. You have to worry about dust and soot. And of course, people don't like nuclear plant in their neighborhood. Personally, I don't care, but most people don't like it. So natural gas can now be put into the middle of a city. And this allows you to do what is called distributed generation. You can build small plants, highly efficient, using turbine, combined cycles, that is turbine and steam engine, and then, in addition, use the hot water that comes out at the end for local heating. In other words, for cogeneration. And that is what we are now concerned about. I'll show you a flow diagram of what you can do. You burn the gas in a turbine, out comes hot gas. Hot gas runs a steam plant. Out of the steam plant comes hot water. The hot water is used for cogeneration, that is for heating buildings, laundry, desalination, you name it, all kinds of applications. Out of this comes warm water, and you put that into sewage ponds. Those little bugs love warm water. They work harder, and they do a better job treating sewage if the water is warm. So you have a huge advantage over existing plants in that you do not have to dispose of waste heat, because essentially there is no waste heat. You're getting close to the ideal of 100% efficiency. So our energy future, I would say, is bright. I have some wonderful quotes here from Obama. He said he would make electricity prices skyrocket. That was during the campaign of 2008. And after losing on cap and trade in 2009, he said, there are other ways to skin the cat. Maybe remember that. That was when he sicked the EPA on its war on coal. And then he has recently announced that his most important policy issue, if he's reelected, would be climate change. Unfortunately, candidate Romney hasn't said anything that I know of, but I could be wrong. I may have missed it. So let's hope that he's moving in the right direction or has the right advice. I want to tell you just one more thing. We're actually doing something about this. This is my final statement. We've decided this is an interesting opportunity, and we should really be willing to put our money where our mouth is. So we've set up a company, a corporation, a profit-making corporation, which will build one of these combined cycle plants with cogeneration in Crystal City. Crystal City is a subdivision of Arlington, the city of Arlington, Virginia. I live in Crystal City. It consists of high-rises, office buildings, apartment buildings, and hotels. Ideal. And we have a sewage treatment plant there run by the city, which has real estate available. That's where we'll put the plant. So we've incorporated, we have a board, we're drawing up a master plan, and we hope to finance the operation in a way that will turn out to be a sound business. And we'd like to encourage the proliferation of distributed generation throughout the United States. Thank you. I see Art smiling. He seems to like that.
Every time I read about natural gas conversion, making white crude, they keep talking about billions and billions of dollars for a plant. So are there any good way? I know there's a Fischer-Tropsch conversion process, and I think there's a couple others. Are there any way that they can start making plants that would not, could be effective on a short-term basis or a quicker
I'm having
basis?
some difficulties understanding, and also I have difficulty seeing the bright lights here.
Oil is currently planning to build a plant in the Gulf of Mexico right now.
Could you comment on the, before we relegate coal to...
I'm sorry, ask Jeremy if you could translate or repeat the question.
Yes. And before we relegate coal to no use at all, I remembered during World War II, I think when we eliminated a lot of the Nazis' supply, they developed a process for converting coal directly to diesel fuel, which is quite high in energy content, as I recall. Could you comment on perhaps doing that? I realize it has a, quote, footprint, conversion, but still it's a valuable use of coal, I would think, for diesel.
I'm not a chemical engineer.
Yeah.
However, the technology for converting coal or natural gas or oil into or natural gas, not oil, natural gas or coal into a liquid fuel is well known. The coal to gasoline technology is the Fischer-Tropsch process, which was developed and used in Germany in World War II, and has been further developed and used profitably by Sasol in South Africa. And the fact the plants that are now being built to take advantage of cheap natural gas follow the Sasol formula and will produce, I imagine, gasoline and diesel oil at roughly half the price, unless, of course, regulators get a hold of it and insist that we add ethanol. That will ruin everything.
Dr. Singer, thank you so much for your tremendous work. I know you've spoken on a number of college campuses. I know you went to Harvard to speak there about these issues a couple of years ago, and you spoke at Princeton about these issues a few years ago. Do you see any improvement in the climate on college campuses on this issue?
Improvement in what?
The climate on college campuses. You've spoken at Princeton and Harvard on college campuses. Do you see any improvement?
Well, it depends on your optimism or pessimism. I don't know. I see the climate, environmental activists. I meet up against them all the time. Some of them are actually very good scientists, but they've sold their soul to the climate alarmists, and they've now got so much of a stake in this that they're unwilling to move back. I don't know how to deal with that. Maybe the next speaker will tell us.
I'd just like to call your attention to a recent book that I bought. Professor Thomas Gold from Cornell University wrote it shortly before he passed away. Unfortunately, he's gone now. But he was an astronomer that was advocating the deep drilling for oil and gas. He says, if you look into outer space, look in the Milky Way, you see methane floating around in between the stars. There's hydrogen gas and there's methane gas in outer space. So he says when the sun was condensed and when the planets were condensed around the sun, They included methane as part of their ingredient, so the Earth must be saturated with methane. If you go too deep where you've got molten rock, of course the methane has been destroyed thermally. Near the surface it's probably evaporated through cracks. But he says you've got to go down, 10, 20, 30,000 feet, you'll probably find all the methane. And in those conditions, the pressure and temperature is such that some of the methane will get converted into high molecular weight petroleum. And I think we're beginning to see that. For instance, this BP well in the Gulf of Mexico was down to something like 25,000 feet. So I think we should be giving Professor Gould's legacy some credit for discovering these deep deposits. He says, how could ancient forests or ancient dinosaurs have been buried so deeply?
Thank you for your comment.
Fred, I'd like to share with you the experience we've had in Mississauga last election. Do you want me to hold it? We have a problem in Canada and many other places called NIMBY, not in my backyard. And they wanted to build gas-fired generating plants in Mississauga, and the population were very upset. They were fearful of pollution from burning gas and also threat of explosions from gas explosions. They happen quite often in some places. And so the politicians had to cave in because there was an election coming, and even though they'd committed a lot of money to building these plants, they eventually canceled them, and they spent hundreds of millions of dollars to move them outside of the cities. So I just wanted to point out that building a gas-fired plant in the city is, while it may seem benign, has these issues with the public. NIMBY, people don't want these firing explosions in the threat, the fear, the risk. So they were moved out of the city, and huge amounts of money were paid compensation of the developers to move them.
Thank you for your comment.
Fred, thank you for your usual good comments. Two remarks about the Romney energy policy that you or the other people should be aware of. Number one, if you go to the I'm not making a picture, I'm just giving that information. If you go to the Romney campaign website, they do have a page that identifies their energy policy. And it does spell out their basic plan, and by and large, it generally makes sense. Second of all, the RNC, the Republican National Committee, started meetings last week to come to agreement as to what their national energy policy will be. And they had meetings last week in Washington, and most of the attendees, from what I understand, from people who were there, were lobbyists, naturally, and not necessarily lobbyists from the right side of things. But you should know that they just started last week a website, so any citizen can actually make suggestions as to what the energy policy ought to include. So that just went up last week. So those are two developments. We're trying to meet with some of the Romney campaign people. Harold Hamm is his senior energy person, if anybody knows him, but they have a team of about 5 people that are dedicated to their energy policy. So some of them are good, some maybe not so good, but we're trying to work on that ourselves.
Thank you.
I just had a thought of maybe gilding the lily here, or carrying coals to Newcastle would be more appropriate, but just I had an observation about the low prices of natural gas, and it's just that, well, the bottom line is that, to me, it highlighted the value of education, because when I see that, I think 100 years ago, 50 years ago, that would have been an unqualified, wonderful development, and you know, for everybody. But in today's culture, what scientific and technological achievement and lowering energy prices and so on accomplishes, to some extent, it's a mixed blessing, because it delays the consequences of the vermin who are anti-freedom and anti-science. It delays the consequences of their actions and thereby ameliorates the rage felt by the average person and postpones the day when there really is when they exterminate the vermin, so to speak, politically speaking. So from the long run, there are some negative consequences to doing good in a culture that holds the wrong ideas. So that's the only comment I have to make, really.
Thank you for your comment.
Sir, you didn't hear the first question, which you couldn't answer, but do you see breakthroughs in the cost of converting natural gas to liquid fuels? The plants cost billions of dollars. Are there breakthroughs coming and that would really make it more economical with small plants? You hearing?
He wants to know are the costs going to come down for converting natural gas to liquid fuels?
With
That's very hard to say.
Small plants.
Look, the natural gas situation is such that that people who drill for dry gas are giving up because they can't make enough money. The people who are making money and producing natural gas are those who are drilling what are called wet wells, where they're producing oil from the well, and gas is a byproduct. They make their money, they recoup their investment on oil. And the natural gas is kind of a byproduct. They could almost give it away. So they're happy to get $2 an MCF. Whether this will be enough to meet the demand, I don't know. The demand is rising rapidly, aided by the fact that EPA is really involved in a war against coal, which is making coal-fired power plants extremely expensive. In fact, they will not allow the production of new coal-fired power plants by setting CO2 limits. Except, they say, if you can dispose of the CO2, sequester it and put it away underground. That technology is not there, and it's not economic, and it's dangerous. So essentially, they're outlawing coal plants. The mercury standards that were mentioned yesterday by Willie Soon are also working against coal. And if they have to retrofit, what utilities will do is they'll simply close the existing coal-fired plants, replacing them with gas. And that will raise the price of gas. At the same time, if there is really a great move to turn natural gas into a liquid fuel, this will lower the price of oil. The demand for crude oil will disappear. Well, will not disappear, but will go down. And I can see the price of oil falling to $60 or less a barrel. I'm talking about crude oil. From its present $90 or $110, which it was about a month ago. So it's very hard to predict how prices will move. And this is one reason why companies are very reluctant to make big investments in either gas to liquid conversion or into gas-fired power plants. They would have to convince their public utility commissions to allow pass-throughs on fuel price increases. And it takes time to convince the PUC of this. So there's going to be a hiatus. And I'm afraid we may have actual difficulties, real brownouts, if not blackouts, as EPA moves to essentially make coal-fired power plants impossible. On the other hand, there are court actions possible. the various standards that EPA is setting are going to be challenged in court, particularly the mercury standard, which is ridiculous. It's going to be challenged in court, and that will take time. And in the meantime, the existing coal-fired power plants may continue to operate more or less as they are, hopefully supplying us with needed electricity.
Just quickly, I'd like you to comment on something that you stated and then you moved through quickly. You said you weren't sure what they were measuring in the way of surface temperature, and the reason it piqued my interest, if you look at groundwater, the whole world of groundwater remediation and so forth, control, what have you, we do not know how to measure the level of pollution in a groundwater well. But it was so necessary to move on with the science, or at least the policies, they ignored it. And it became, the numbers became real, and they're not. I mean, you can't defend them technically. It seemed to me you were saying the same thing on surface temperature. And I'd like to hear your comment on exactly how real is, do we know what we're measuring?
He'd like you to comment on the surface temperature data and why it's unreliable, why it's different.
The expert in this field currently is Anthony Watts, who has described the sorry state of surface stations in the United States. There's every reason to believe that the situation is worse in other countries. In other words, the weather station data are not reliable. Even if they were, the urban heat island effect has not really been eliminated. The more recent work by McKittrick and Patrick Michaels, I think, demonstrates this. More than that, we have looked into another aspect. We find that most of the weather stations, overseas at least, are located at airports. Why is that? Well, that's where you need good weather stations, because weather information is important at airports for air traffic, for safety. So the best stations are located at airports. If you look at airports, they have been expanding everywhere. My own airport at Dulles, outside of Washington, used to be out in the countryside, way out in the boondocks. It's now a sister city to Washington, surrounded by high-rise buildings, office buildings, concrete, asphalt. They've added runways. The traffic at Dulles is so large that I hate to get out there and fly out of Dulles. It's a hassle. In other words, the urban heat island effect has expanded, and at airports, the effect is extremely large, so that airport data do show a warming, and you would expect that. So I agree. From a world point of view, we can say airports are warming. That's not necessarily global warming. And the proxy data seem to confirm that. Of course, the proxy data, the tree rings, those trees are not at airports. They're somewhere out in the boondocks, in Mongolia, Africa, wherever they come from, but they're not at airports. So in this case, I would say the proxy data are probably more reliable indications of surface temperature than the weather stations. I hope I've supplied some of the answers. I don't have all the answers.
Professor Singer, I want to thank you very much for the work that you've been doing. I enjoy your presentation today. I have a question. I understand that the endangerment finding from the EPA on carbon dioxide has been challenged in court. How did that ever come out?
The endangerment finding of the EPA on carbon dioxide, there was a court challenge. What's the status of that?
Unfortunately, we've lost the court challenge for the time being. I'm one of the plaintiffs. That is to say, my organization is one of the many plaintiffs that filed a challenge to the EPA on their endangerment finding for carbon dioxide. Our challenge was based on science. The legal challenge was based on the fact that EPA was supposed to make an independent assessment. They did not. They simply used the IPCC. And as I've indicated in my discussion today, IPCC's evidence for anthropogenic global warming is extremely weak, I would say non-existent, certainly not 90 to 99% sure. So we used that. The court decided that they're not going to get into science. In fact, they were explicit about this. They said, we're not going to consider science. We're not going to reinvent the atom. That's not our job. We defer to the EPA, to their technical expertise. It's quite common for courts to defer to the administrative agencies on scientific issues. And unfortunately, they did that. And unfortunately, the three-man panel was unanimous, which means we have little chance of getting an en banc decision from the appeals court, and probably little chance of getting it into the Supreme Court, because the Supreme Court probably doesn't want to touch this thing, having made their fatal decision in 2007 that CO2 should be considered as a pollutant. Poorly defended by the Bush administration, very badly handled. The Solicitor General just conked out. He did a very poor job of defending the position and was impervious to any scientific arguments. So the only hope is that the new Congress in January will take as its first order of business, will decide, simply rule legislatively that EPA has no business regulating carbon dioxide. Congress can do that. Congress should do that. Congress must do that. But they must have both House and Senate and hopefully the White House.